Hi, this is Mr. Max. So I am doing simultaneous linear and quadratic equations. That means you're going to solve a linear equation and a quadratic equation at the same time. So obviously, the quadratic equations, you always see the little squares there. All right, so the objective here would be for you to take the linear equation, which is x equals to 3 minus y, and substitute it into the linear equation for x there, because it's already x equals to. So the objective is always to rearrange or to have an equation y equals to or x equals to for the linear one, and substitute that equation subsequently into the quadratic one, the one that has got the squares there. All right, so I'm going to take that 3 minus y and I'm going to substitute it here everywhere with an x. So that's going to give me 3 minus y all squared plus y squared equals to 5. So you're going to multiply the 3 minus y times 3 minus y. I hope you know how to do binomial expansion. So you get 9 minus 6y plus y squared. Right? Add with this y squared is going to give you 2y squared here minus 6y plus 9 equals to 5. So all quadratic equations are supposed to equal to 0. So you bring that 5 becomes a minus, and then you have 2y squared minus 6y plus 4 equals to 0. So here you can divide 2 out by 2, because 2 goes into 2, 2 goes into negative 6, 2 goes into 4, and 2 goes into 0, leaving you with y squared minus 3y plus 2 equals to 0. Now this quadratic equation here should definitely factorize, and its common factors are y minus 2, y minus 1 respectively. So we let each bracket then equal to 0, and that gives you one value for y is equal to 2, or another value for y is equal to 1. So now you have your two y values, so you'll be substituting them into this equation, x equals to 3 minus y. So when y is 2, x is 1, and when y is 1, x is 2. So the solutions then are the points 1, 2, and 2, 1 respectively, because they say write down the coordinates of the points of intersection. The second one here, you have y plus x equals to 3, and then you have x squared minus 2x plus 3y squared equals to 2. Right? So you take this one here, the linear one. Maybe you say y equals 2 or x equals 2. It's totally up to you. So I rearrange the equation to make y or x the subject of the formula. Right. Then I substitute that y equals 3 minus x for y into the second equation. And if I do that, and I have to clean this up a bit, and that's going to give me x squared minus 2x plus 3, and in brackets 9 minus 6x plus x squared equals to 2. Remove the bracket by multiplying the 3 over with everything. You have x squared minus 2x plus 3x squared minus 18x plus 27 equals to 2. And all quadratic equations equal to 0. So you bring that 2, becomes a minus 2. And it cleans nicely to 4x squared minus 20x plus 25 equals to 0. Now this factorize the two numbers I'm looking for is negative 10, and negative 10 gives you 100. Two numbers multiply give you 100, 4 times 25, and when added is negative 20. The numbers happen to negative 10 and negative 10. Well, if I take out common factors and I factorize by grouping, I will have a repeated root or repeated factors, 2x minus 5, 2x minus 5. So I just write it once. Remove that square by taking the square root of 0, and you solve this answer, then x equals to 2.5. So now x is equal to 2.5, so I can find my respective value of y by substituting that 2.5 into the equation. Y equals to 3 minus 2.5, so my solution is 2.5 for x and 0.5 for y. The third equations that I am bringing, that pair of y equals to 2x squared plus 2x minus 6, the other one is y equals to 3x plus 4. So the nice thing about this equation is that both are starting with y equals to, and since one and the other starts with y equals to, I can just equate the two to each other. So I can say 2x squared plus 2x minus 6 is equal to 3x plus 4. And then I rearrange the equation so that it can equal to 0. And then I left with 2x squared minus x minus 10 is equal to 0. Right, two numbers multiply give you negative 10. And if you add them give you negative 5 is negative 5 and positive 4. So then I obviously factorize by grouping. Then I have 2x x plus 2 minus 5, x plus 2 equals to 0. So my factors are 2x minus 5 and x plus 2. Right, let each equal to 0, and then you can actually solve for x. So 2x is equal to 5, or x is equal to 2.5, or 5 halves. Then the other solution is x is equal to negative 2. So now I'm going to take my linear equation y equals to 3x plus 4, and I'm going to substitute when x is 2.5, and I get 11.5 as an answer. And I'm also going to substitute when x is equals to negative 2, and 3 times negative 2 is negative 6, and negative 6 plus 4 is negative 2. So these are my solutions. If x is 2.5, then y is 11.5, and if x is negative 2, then y is negative 2.